Welcome back to the podcast devoted to JavaScript. This is HashBang. HashBang features interviews and discussions about the latest in JavaScript and the JavaScript ecosystem. Brought to you by OK Grow, a JavaScript consulting and training company.
Welcome to HashBang. I'm Paul Dowman, founder of OK Grow. With me today is co-host Robert Dickert. Robert's a software engineer at OK Grow and previously was with the Meteor Development Group. Today, our guest is Johannes Schickling. Johannes is CEO of Graphcool. Hey, Johannes. Johannes is the CEO of Graphcool. He's as a serial early adopter of new technologies. You name it, he was one of the first people using it and a very well-known person in the GraphQL community. Welcome. So Johannes and the team at Graphcool recently open sourced Prisma. And my goal for today is to try to understand what Prisma is, where it fits in the architecture of various types of apps, including over the life cycle of a product from a prototype to something more mature. So tell me, Johannes, when did you guys first release Prisma?
Right. So now that it's like somewhere at the beginning of February, that's like roughly 2 or 3 weeks ago. So that was, I think, on the 16th of January. So that's sort of like the end of a long programming cycle. So we've been working on that pretty much since like for the last 5 months. And yeah, the adoption so far has just been overwhelming. So we've like seen like a ton of feature requests and people now just after 2 or 3 weeks of it being released, people are putting it into production, deploying it on Kubernetes for their mission critical apps. So that's been super amazing.
Cool. That's awesome. Well, I want to, before we get into what Prisma actually is, maybe we need to do a really quick explanation of what GraphQL actually is for anybody that's not yet familiar with it. Can you give us that quick little overview?
Sure. So GraphQL, you can think about GraphQL in the typical case of how it's being used is as an alternative to REST APIs. So it has originated at Facebook, where at Facebook you have like very complex front-end applications. And with these complex front-end applications, that typically means that the data requirements of these applications is also very, very rich and very complex. So the APIs need to support that. And typical REST APIs are typically not a great fit for that. So they needed to turn around these requirement mechanisms. So, and what GraphQL does instead of REST APIs, for REST APIs, you just have like endpoints that give you statically structured data. And it's sort of it goes into the design decision when you're building this REST API, how much data you include there, whether you should like layer all of your data out flat, that you say you have an endpoint that gives you all of your images if you're building Instagram, or whether you say it gives me back all of the images, but also the authors who's created these images and the friends of these authors. So whether you keep your APIs data very flat or very, very nested and very heavy. And either way, it sort of results in problems. So if you keep it very flat, then you have to do a lot of queries in the front end. So if you imagine building an Instagram, you need to get all images and you need to iterate over all of these images, get the author information for all of these images. If you pack everything in there, you might fetch way more data than you actually need, which is very, very problematic on mobile connections. So what GraphQL does, it turns the entire thing around. So instead of the REST API already telling you this is the data that you're gonna get back, you tell the GraphQL API, actually, I'm just interested in this piece of information. So it looks like this query that you're sending to your GraphQL API kind of looks like JSON, but just with the keys. And the server is responsible for fulfilling the query that you're sending. So it's very similar of like how you think about a SQL database, that you send it a SQL query where you select, I want to get this field, this field, this field, and the SQL server sends you exactly that information back. It's very, very similar to that. But instead of it being a query language for a database, it's a query language typically for APIs.
Query language for APIs. That's cool. And you touched on a couple of benefits, like not overfetching, not underfetching, just one network request, not N+1 requests.
Exactly.
And what I hear a lot from the more enterprise type people is that they're very excited about the prospect of potentially not needing to version their APIs, which is another benefit. Okay, so that's GraphQL. Now that we know what that is, Prisma is a product that uses GraphQL. So tell us about Prisma. What actually is it?
Right. So for the people who are familiar with what GraphCool, for example, is, which started out as a backend service, and then later on got turned into an open source development framework. So for the people who are familiar with that, we've basically taken out the core of the GraphCool framework and made that available as a standalone component. That basically turns your database into a GraphQL API. So, and this solves one of the very typical tasks that you have to do when you're building your own GraphQL server, or like any API actually, that you need to, when you want to implement an API, you need to get data somewhere. So you need to create this mapping from one database or multiple databases to fulfill the design of your API. And that's a very common thing that you have to do as you're implementing GraphQL servers. So Prisma helps you with that. Prisma already lifts your data that you have in your database or multiple databases, provides that as a GraphQL API. And this GraphQL API you can reuse sort of as building blocks, or you can think a bit about it as a GraphQL ORM to some extent, without the negative side effects of an ORM. We can also talk about that later. But you can use your GraphQL API to build your own GraphQL server. So and that's very much how you would use Prisma. So Prisma is a more technical term, might be a GraphQL database proxy.
I think this is really interesting to me, because when I first heard about it, I was assuming that it was sort of like it was your entire back end, like it's like Firebase or something like that. But when I looked at the description of Prisma on your website, which was really good, by the way, it described an architecture where you go through an application server and then through Prisma to your database, and it sounded like it gave you a fair amount of flexibility in terms of like being able to maybe expose parts of the GraphQL API for your database or not expose it as you choose. I'd be really interested in having you kind of talk through kind of the flow to like from a mobile app, say, and then how you would respond to different areas and how you get flexibility through this architecture.
Okay, perfect. So yeah, there are a couple of things to touch on. So actually, this GraphQL API that you get for your database, there are two ways how you could use that. So in sort of as you're building out an MVP, a prototype, or as you build out internal apps that live in an authenticated, trusted context, you could actually say, let's let the front end talk directly to this GraphQL API for your database, as you don't want to build heavy authorization logic or any sort of business logic, as you first like want to get like an MVP going, or for internal apps. But the more typical case, as you're building real production-ready servers, is that you would use this GraphQL API that Prisma gives you for your database, and you use this API as a data layer, as a data mapping inside of your own GraphQL server. So a typical stack might look like you have your client that's like a mobile client or a web page or a VR headset, whatever you have. That's probably using Apollo client or Relay or something way more simple. And that directly then talks to your GraphQL server that you deploy wherever you like. So you might deploy it on AWS Lambda, Now, Heroku, or if maybe it runs on your own Kubernetes cluster. What's also a very interesting perspective is that it might also talk directly to AppSync from AWS, for example. And as you're implementing your GraphQL server, instead of manually creating this mapping to SQL queries, you would basically delegate your GraphQL data dependencies in these resolvers to this Prisma GraphQL API. And that's then on its own, that figures out, okay, this data should live in this Mongo database or in this Postgres database. So ultimately, what you get out of this as a developer is you want to write as little code as possible, and you want to like move fast. And what's very problematic as you're building out bigger GraphQL servers that you want to change and evolve quickly is that you end up writing huge SQL queries in your GraphQL resolvers or whatever database you're mapping to. And as you want to evolve your server, or as you're developing it, you typically need to touch on a lot of ends as you're changing something that's brittle and that's error prone. And that's sort of one of the core parts, one of the core problems that Prisma is making a lot easier.
Okay, so if I could paraphrase that and just check my understanding. So you've got Prisma, which is kind of like proxying an actual database, providing the API for that database with some automatically generated CRUD, like GraphQL with some queries and mutations that give you your basic operations on your data. You could just directly go to that, but for a real app, you're probably going to have your own app server with your own resolvers. Those resolvers will probably make calls basically to Prisma for your read and write operations. Correct so far?
That's correct. And the interesting part is like how that really works is based on GraphQL bindings. So this is sort of what's the magic part behind implementing these resolvers in an efficient way that actually saves you time and effort to build these resolvers.
So in your resolvers in your own app server, you've got GraphQL bindings available, which are based on the schema. You're guaranteed that they're going to be the same as the schema of your database, and you're going to be able to make queries directly in whatever language you're using. I mean, let's say it's JavaScript. You're going to have directly a JavaScript object and available from the context in your resolver that you can do sort of ORM-like functionality, right? So it's interacting with your GraphQL API through objects in your typed objects in your language.
Exactly. So you really have like these two different layers. One is like you have Prisma as a GraphQL database layer, which basically turns your database, your existing database or new database into a GraphQL API. And the second layer is as part of the code of your application server, you have GraphQL bindings. So GraphQL bindings are not really bound to Prisma. Prisma is just like, that's one great way of applying it, that it gives you sort of this GraphQL ORM object that literally maps your GraphQL API into a programming language. So it's really interesting what you can actually do with GraphQL bindings in general, that you would take, for example, you want to build out an application that uses the GitHub, the GraphQL's GitHub API or the Yelp's GraphQL API. So what you can do is like you can create a GraphQL binding for any sort of GraphQL API and use this other GraphQL API also sort of as an ORM. So that opens up a whole new world of how you can recompose existing APIs. And the way how I'd like to think about this is like that you can finally think about APIs as like building blocks, almost like Lego bricks that clip together based on GraphQL type system. So and that especially becomes interesting. Like you mentioned, you can do this in multiple languages. Especially is interesting if you're using something like TypeScript or Go, where you can map the type system of the GraphQL API to the type system of your programming language. That gives you, so whoever has like this magical first experience using GraphQL in the playground or in graphical, where you get auto-completion and you get help if you have a typo somewhere, and you get static analysis for your queries, you now get the same thing inside of your programming language, which is a huge deal as you're building out more and more, as you build out your backend into multiple GraphQL microservices, and they talk to each other and they reuse each other. You can get compile time safety across these microservices.
So whether or not you're using Prisma, you should check out GraphQL bindings. I'll put a link in the show notes to a blog article that you guys wrote that explains that pretty well. That actually, your description of being able to use APIs as building blocks made me think of something else I wanted to ask you, which is about schema stitching. So can you avoid having to write resolvers in your own API, in your own GraphQL API, and basically delegate to Prisma until the time that you need to take over? Is that how you might? Would you work that?
So GraphQL bindings are very much like they're using schema stitching under the hood. So so far GraphQL bindings are an imperative way to use schema stitching. So for the people who are new to GraphQL and don't know what schema stitching is, so schema stitching basically allows you to take one or more GraphQL APIs, GraphQL schemas, which expose a type system, and also have resolvers bound to them that implement how you get back that data. So and that you can combine them and stitch them together. So this lends itself really well for you splitting up your backend into microservices, where you say, I have a GraphQL microservice responsible for user management or for messages or for the checkout process of my web shop. And you have a layer in front of that there's more and more of this term evolving of a GraphQL gateway. So it's basically an API gateway that uses schema stitching. So this is something that AppSync is doing. This is something that Apollo's engine is doing. So, and you can stitch all of that together in one bigger GraphQL API. So, and so a reference implementation of that is available in the JavaScript package called GraphQL Tools, which is led by Apollo. So this exposes a very low-level utility function of how you can use schema stitching in your own GraphQL server, but that on its own enables so many different ways and packages how you can use that. So GraphQL binding is, for example, an imperative but very intuitive way of how you can use schema stitching to build your own GraphQL servers based on other GraphQL APIs. But there's also more and more tooling available how you would do the same thing in a declarative way. So it's really, and you can combine these two. So it's really a matter of whether you rather want to put everything together in a quick way and you don't want to write real imperative code, or if you want to have the control that you do have in code, that you can put this like in an if statement and implement some business logic.
Okay, so maybe I misunderstood something. Send me in the right direction if this is a dumb question. But when you're writing your first resolvers in your app, in your own application server, and they're going to be delegating out to Prisma, so you have the option to via GraphQL bindings to make the same query. But if you're not adding anything in the logic, do you still have to write a resolver? Is there any way to?
So right now you can do so either by implementing a resolver that would literally just delegate that, but there's also a convenience API that would literally just pass it through, that you don't have to implement that resolver. So there's these both ways available.
Okay, cool. So it sounds like a good way to get an MVP or a prototype going, and then you can incrementally start taking over the logic by doing more in your own resolvers.
Exactly. So this is definitely something we see also with the concept of like schema-driven development. So that you would, and this is something that GraphQL now enables, and can help to like improve the collaboration between product teams. That you say actually even designers can define the data model that they want to work with in GraphQL SDL. They can pass it over to like a backend development team or to a full stack developer who can then say, all right, so they need this GraphQL API. Maybe I just use a mock implementation of that. There's, for example, a library called GraphQL Faker, which just allows you with GraphQL directives, which are like these code annotations inside of your schema that you say this always should return an email address. So you can create in a super quick way. You can return you can build a mock API, or you say declaratively map that to an actual data source being Prisma, or you can, like you said, incrementally take one resolver or one field at a time to say, now I want to add more business logic. So it's a really smooth transition from building out an early prototype that doesn't have to use Prisma, but like then incrementally introduce that until you end up really with a production-ready, highly scalable app.
That sounds really intriguing. I really like the idea of the GraphQL binding. I really want to play with that and make my modular APIs with it. I'm wondering, like, we're talking like fairly abstract terms here. And I'm wondering for people that maybe haven't had as much exposure to it, is there a concrete example or maybe an example of an app you can think of that has kind of gone through this process where they've, where they've really benefited from it, or like it's like where it demonstrates what is happening in this process?
So are you talking about schema stitching, about like, or concretely of people adopting GraphQL bindings, or in general of people adopting GraphQL? And also one note more about it seems very abstract. What I'm seeing is with the entire ecosystem, right now everybody sort of thinks about GraphQL in this like very low level way. Whereas I think a good analogy is like people so far think about GraphQL as like the way how they interact with it, sort of like as jQuery. But like there are more and more concepts evolving that rather brings you up to like higher concepts like a component model. And nowadays everybody thinks about React, like nobody thinks about document get element by ID anymore. Everybody thinks about component models. And this is sort of like the same evolution that the ecosystem goes through at the moment. So like once you're more familiar with that, and once the ecosystem has really settled on something, this actually gives you a better abstraction to talk about these things. So this was just a couple of philosophical comments on your part. Yeah,
absolutely. Yeah, that's really interesting to me to see this evolution of the ecosystem. I totally agree that people started out with extremely, like, just looking at it from a very low level point of view. And
so to add on your question, sorry, I didn't want to drop that. So we for example, there are a couple of companies that already have also written about their process of like moving to schema stitching and moving to other GraphQL higher order concepts. So for example, Artsy is one of the companies who very early also started to adopt GraphQL. And to adopt GraphQL schema stitching. So their use case, for example, is that they actually have split up their backend into multiple microservices, and they need to correct me if I'm wrong here. I'm just paraphrasing from what I remember, but they've like built multiple GraphQL microservices, and they've built this API gateway layer before on their own. And I think WorkPop with Abi, for example, has done something very similar. And so they needed to build that layer very manually before. So they needed to like sort of implement it very naively, that they say, oh, this GraphQL query comes in, then they know, okay, this wants this information, so I probably need to send an HTTP request to this other GraphQL API. Whereas GraphQL has like all of the things that you need to make that a lot more intuitive. So it has a type system. You can sort of easily map if this data is required, declaratively bind this to this other part. But whatever you can do declarative, you can also do imperatively if you need more control over how that should happen. And both of these ways of how you use it is very powerful.
That's great. I wonder if we should talk at all about the ORM question, like the mapping of GraphQL queries to the database, and like how that's accomplished, and for people who are worried about flexibility, if they should be, or whether it's worth it anyway.
Right. No, that's a great question. So for us, I'm sort of hesitant typically to use the word ORM, since it has like so much stigma and so many negative connotations. Like it's typically when people think about an ORM, they think about deep moments of sadness and disappointment when they saw like, oh, this looks like such a nice API. Let's use that. Like over the first couple of months, they like sort of gain a lot of development speed, but at some point they realize, oh, I cannot actually, this API doesn't allow me to express this. Or they put it out in production, you come up with like these weird workarounds, and then another typical problem is that you hit severe performance problems. Since if you think about it, like what an ORM typically does, it's like it's a nice DSL, like active record in Rails has showed like, oh, this is how a nice API for that could look like. But what it does eventually is like it's a synchronous function that translates the data requirements that you've expressed through this DSL, translates that in a typically unoptimized SQL query. And that works well while you're still developing with like your 10 data sets or something. But as soon as like that scales up, and you haven't really, it doesn't really fit the perfect use case, and like doesn't work with the indexes that you should be working with, that doesn't scale. So what a typical development or a typical life cycle of a project that uses an ORM is that they say either they're already experienced enough, they don't use an ORM, they directly write these queries manually, or they use, so Go, for example, it's very popular for Go to use like query builders. So you don't have a fully fledged ORM, but you get a bit of a better abstraction of your database, but you're still very much in charge of building this query yourself. Since typically if you're using an ORM, you just end up rewriting it using direct queries yourself to just being able to have control over the performance. So we had all of these problems in mind as we were designing Prisma, and it really splits up the responsibility of an ORM in two parts. So one part being the nice DSL that you get for writing your queries, where you can use GraphQL and you can use the power of your programming language to express these data requirements. And like this is literally what GraphQL is designed for, that you can express data requirements. And the second layer, which is what Prisma is, this is where we don't in a synchronous way execute these queries, but this is sort of the intelligent version of the data resolver part, where we implement all of the best practices of how you would implement it yourself in resolvers, but where we can do a lot of, since this is a long-running stateful component actually, we can implement a lot of optimizations. So we can put in caching, we know about the indexes, we can, like whoever is familiar with the data loader pattern that you typically see in GraphQL JavaScript servers, all of that we can really push to the extreme and turn any sort of GraphQL query into an efficient execution, since we know about the underlying database. And even more exciting is that typically ORMs very much encourage you to, whatever data you want to store, put it all in one database. What you nowadays have is actually like this, backend teams now embrace the specific different kinds of databases. So now you have like maybe a Postgres database at the core of a backend, but you also have an Elasticsearch for specific aggregations, or you might have something like Timescale or Influx for time series data. So for your backend, it becomes more important that it maps to multiple databases. And all of that part, Prisma basically takes care of. So you get one GraphQL API that maps to different kinds of databases depending on where the data should be actually stored. So that's sort of a long-winded answer, probably a bit too overwhelming at the beginning to the question yet.
So you can have Prisma with multiple backends, and you're just talking to Prisma, but it's getting, say, the users from Postgres and something else from a different database. Is that possible now, or is that future roadmap?
So that's not possible now. So what we're working on right now is right now we're supporting MySQL and Postgres really soon. So what we're working on is basically building these database connectors for all different kinds of databases. And at a later point this year, we'll introduce multi-database support that you can say in your data model as you're defining this mapping from how your data model looks like and how that maps to databases. This is where the split point, this is where this translation will happen.
Cool. So what do you say to people that want more control over every part of the stack? Like they want to write custom SQL queries, and I hear what you're saying, that you guys are writing really smart ones, and you're going to do smart things like the way Data Loader does. But what do you say to somebody who really wants to do it themselves for whatever reason?
So the way how we think about exposing the API of Prisma is that it sort of gives you a more pragmatic abstractions for like the 90%, 95% of the cases. And this is like, however you would implement it yourself, you would end up with the same. But we still have like two fallback mechanisms of how you would work directly with the database. So a case might be that you really want to use this specialized Postgres function that gives you like an average over whatever. And obviously we're not going to support all of that in this GraphQL API. So you can do two things there. So either in the GraphQL data model that Prisma uses as this translation from how your data model should look like to the different databases, you can say this field actually resolve it using this query. So you can hard code it and Prisma takes that into account while resolving it. Or you could say, actually don't bother Prisma with that. In the GraphQL resolver level, since you have this nice mapping of like, here you have a GraphQL schema where you want to implement resolvers for fields, and that maps really nicely to Prisma or to this GraphQL API. So you could just ignore that over here and say, here, this field, I implement this resolver myself that talks directly to the underlying database. So this puts a bit of the burden still back on your side, that you implement the data loader pattern to make that efficient. But that was very much, that went into the entire design process from the beginning, that you, when you need to drop back, you can.
That's actually really cool. I think a lot of people will breathe easier just knowing that they can do that. So then what about, I guess a migration, what would be the migration path further on? Because, another taking that logic along the same path and going further, you might think, well, what if I need to get rid of this? What if I need to start doing these types of things for so many of my resolvers? Can I just take it over? And if you have to remove Prisma from your architecture at some point, is there a clean path to doing that?
So, I mean, the way how there are two migration paths. One is like, how would you, for an existing application, adopt Prisma? And how would you say, now that I have Prisma, how do I, like, for whatever reason, I want to get rid of it again? How does that work? So for the latter example, how you want to remove Prisma again from your stack, Prisma really sits like between your application server and your database, and it stores just like there's no crucial information living in Prisma. It's just this translation layer. So the same way as you don't need an API gateway, you could also, your frontend could talk to like 15 different microservices. In the same way, you don't need Prisma. So you could just say, actually, let's remove my GraphQL binding that talks to this Prisma layer, let me just like write these horribly long SQL statements myself and talk to the database. Like you could entirely do that. There's no business logic that really lives in there. I mean, we put in caching and so on to make your data queries faster, but ultimately you could just it just gives you a nicer level of abstraction. So again, the analogy is like, if I have my front-end application, I've currently written it in React, you can also get rid of this mental model and like start writing a lot of DOM manipulations yourself, but the ultimate product will look the same.
Cool. So you can incrementally adopt it and incrementally or not migrate away from it. That's cool. Okay.
No, we totally believe that this is like a fundamental requirement for developers that evaluate the technology. That's not just like easy to adopt it, but also doesn't lock people in to that if they for whatever reason want to migrate away from it again. So and like Prisma itself helps you actually to de-risk your vendor lock-in of databases itself, or we want to make Prisma truly multi-cloud, that it runs on cloud native and runtimes, so that it makes it in the same way as Kubernetes, for example, makes it easy to move like your entire stack from one cloud to the other. This is what we want to make possible with Prisma, that you can move your database stack also.
Do you want to talk at all about, and this is a little bit of a shift in direction, so if I'm missing anything, Paul, that you want to get to, we can pause this. But do you want to talk at all about hosting Prisma? I know it's open source, so you can host it anywhere you want to, and you also have Prisma Cloud. And maybe you could talk about like what people's options are and maybe some recommendations of how they should get started on that.
Right, sure. So as said, in the same way as we don't want to lock in people to certain technologies, it's also important that people can just roll out Prisma in production without needing ever to worry about paying a single dime. But there still is for the people who rather want to move fast and don't worry about managing Docker containers and so on, who don't want to think about infrastructure. This is where we also provide Prisma Cloud. So Prisma Cloud, the way how it works is you sign up, you can connect to wherever your database lives. For example, AWS, you connect to your RDS database. So we then see, okay, this lives in US West 2. Let's spin up a Prisma cluster for you in that same region that is close to your database. So you don't need to worry about managing Prisma. Prisma runs on Docker, so that you don't need to worry about that, and that you can just use that as a pay-as-you-go as a serverless model. So that's one, solving the hosting part, but we are also trying to really improve the workflows around that. So that includes, for example, backups and database restores. That includes collaboration around that for your team. But also one of the core features of Prisma Cloud is the data browser. So you can kind of think about that as do you know PHPMyAdmin?
Yes.
So it sort of solves the same problem of like what PHPMyAdmin tries to solve, but like not as much in a 2000 version, but like more meant for today's developers, and it's like rather has more of the feel of like Airtable. So and this is one case that we see a lot of teams now actually requesting us, that they say, actually we're moving to Prisma to manage our entire data, but our organization, our teams, they want to use Prisma Cloud and data browser to work with that data. So their customer success team or sales team can directly work with that application data without other people needing to build like admin applications. And in Prisma Cloud, you can also set up authorization rules that the right team has access to the right data. So it really becomes also a bit of like a data platform for your organization.
You just made me really happy, because this is something that I was talking about literally this week, where you always want to have you have to build admin sort of backends, but a lot of times it can be very basic. And if you had something built kind of like PHP My Admin that you talked about, we at OKGrow, we used to use some options like this. There were some meatier ones. There were before that in Rails there were some good ones, and I've been complaining over the last week or two about like the options for that right now. So you're saying if you use Prisma Cloud, you could get something like that, like a nice UI for it's back end. It's not going to be customer facing, but a nice way to sort of like deal with CRUD operations.
Yeah, exactly. And really like tying it nicely together, that you have an expressive GraphQL API that you can use to, for example, filter through data, but you still have like a nice table-based view on that data with like inline editing. And over time, we want to make that more and more integrate nicely with like other services that you can sync that data to somewhere else. And making that really use case oriented of like how people want to work with that data.
Awesome.
That sounds really nice.
Very cool.
Can I ask one other slightly disconnected question? But you mentioned Amazon AppSync, and that's an Amazon like real-time GraphQL database service. How do you feel it is it a competitor with Prisma, or is it something you use with Prisma? Like, where does it fit in the ecosystem for you?
So AppSync does three things. So it's actually like AppSync is three products. So at its core is what we already touched on as a GraphQL gateway. So it allows you to define a schema. So with AppSync, you can kind of like define your own GraphQL server in a very minimalistic way. So, and eventually they're gonna add declarative schema stitching and so on. So it becomes more powerful. But at a core, you have a GraphQL gateway that you would use like defining your GraphQL schema. And then you need to connect your schema with resolvers. You do all of that through a UI. So you can say, this resolver bind that to this Lambda function, or this resolver bind that to this DynamoDB table. So that's the core where like how you implement these resolvers. You can map that to a set of data sources. The important part here to realize is that you do that part sort of declaratively in a very limited way. So you would use that like it's very intended for mobile developers, for example, who explicitly don't want to build bigger backend applications. They rather want to say like, let me quickly spin something up where it can store simple data, or where it can do this simple query to Elastic. But this is not meant for bigger backend applications that you would put into Git. So that's the third part, and the other part that sits rather in front of the GraphQL gateway is the entire part that actually gives AppSync its name. So that like this client syncing part. So I think this is where they rather want to think a bit about like what Realm is doing with like the iOS and Android client that also talks about database syncing and offline. So this is where this is just the very beginning for them. So they've literally taken Apollo client, forked it, and basically trying to move forward with that, adding these syncing capabilities. So from my perspective, it's rather like this gateway layer is something that Apollo Engine, for example, also wants to do. So that will be a bit of an alternative. And they add with their AppSync client, they add another GraphQL client. So it has to be seen where that is going, since it's a fairly ambitious project, which is open source, luckily. So that's great. And on this data source and the way how we'd like to use that is that you can just use a Lambda function to connect directly to Prisma, so that you can actually use the GraphQL gateway layer, which is distributed and which is like runs on the same infrastructure as the API gateway from AWS. that people can use that together.
Awesome.
Thanks for that.
There is a lot going on right now, and we had a ton of stuff that I wanted to also get to. We're kind of running out of time, so we should probably wrap it up there. Was there anything that I missed that you would like to mention, Johannes?
I think there is enough stuff to just fill a couple of other hours.
Yes.
But I think our blog is also a good resource to keep up to date, or just like read the HashBang weekly newsletter. I wasn't bribed for that, by the way, but this typically also contains a lot of good resources. Yeah.
Awesome. Yeah, and you guys, there's GraphQL Weekly, and I guess if someone wants to learn more about GraphQL in general, I would recommend check out howtographql.com. We, of course, at OKGrow do a GraphQL training and in-person thing, so look at our site for that. And the URL, Johannes, remind me for the Prisma site. What is it?
PrismaGraphQL.com.
PrismaGraphQL.com. Okay, so check that out. And if anybody wants to get in touch with you, what's the best way to do that?
So either find me on Twitter, that's like _Schickling, my last name, or you can also join our Slack. So we have the biggest GraphQL Slack community now with around 7,700 people. So if you want to join there, just go to slack.graph.cool, and this is where you can join.
Awesome. You guys have been doing so much stuff in the GraphQL community for like quite a while now, and yeah, I can see why there's that many people in your Slack. Amazing. So thank you very much.
Awesome. Yeah, thanks for having me. It was super fun talking.
I learned a lot.
Thanks a lot.
That's it for this episode of HashBang, brought to you by OKGrow, a JavaScript consulting and training company. Contact us at okgrow.com, okgrow.com.